let's take a look at question 4. Okay, I'm just going to move this up. I got this so that you can see there is a formula to compound interest. It's your amount, right? Equals your principal, which is like your initial amount, times 1 plus your interest rate in a decimal over the number of times interest is compounded per year. And then over here is the T years. Okay. So N is N here in both places. So let's take a look at option 1. Let's take a look at number 4. You are looking to invest $500 and have 3 different options to decide between. Option 1, an account grows by $30 per year. Option 2, an account that earns 5% interest compounded monthly or 12 times per year. Okay, option 3, an account that earns 5.25% interest compounded quarterly or 4 times per year. So, which account would you choose if you are investing your money for 5 years? So, this is the equation for option 1, 500 plus 30x. So, in 5 years, that's going to be, let's just, instead of x, put it as 5. Okay, and I'm going to pull up my TI-84. And I have 500 plus 30 times 5, and that's going to equal $650. So this equals $650. Now let's take a look at option 2. Okay, option 2 is 5% interest, so we have $500, right? 5% interest, it's growing, right? So it's 1 plus, and then we're going to have, I'm going to have a fraction. I'm actually going to use the equation function thing on my, so you could see it as a fraction. And I'm going to have 0.05 because that's my percent as a decimal, right? And the only reason I have this in a fraction now is because it's not compounded once, right? So we need to account for that, and it's 12 times per year, okay? And then we have an exponent of 12t, okay? And actually, since we're in the thing, I could do it as like this, okay? 12t, and let me see if I can move that over. I cannot, but what I can do is this. Okay, so that it's all making sense. All right, and what does this equal? Okay, when t is how many years? So we're talking about 5 years. So t, being the number of time, is going to equal 5. Okay, so I'm going to take my calculator again, and I'm going to do 500, 500 times 1 plus alpha y, enter, 0.05 over 12, right, because it's being compounded 12 times, right, to the, okay, and I have 12 times 5, okay, all right, that equals 641 and 68 cents. I'm going to round that, so 641 and 68 cents. Okay, and I'm just going to put the dollars here. And we're going to do option 3. Okay, option 3 is going to be similar in the way I write it. So I'm actually just going to copy and paste this and change my numbers in. So the 500 is going to stay the same. Okay, the 0.05 is going to be 0.05, and instead of 12, this is going to be 4, and again, instead of 12, this is going to be 4, and the 5 is the same because it's 5 years. So I'm going to pull up my calculator again, and I'm going to do 500 times 1 plus, okay, alpha y equals 0.0525 over 4, Okay, and that's going to be to 4 times 5. And we enter that and we get 648.998 cents, right? Because I'm rounding. So we have 648 and 98 cents. Okay, so let me okay. All right. Which would you choose the next question, which would you choose if you are investing your money for 15 years? That means T is going to equal 15 years instead of 5. Okay. Ooh, that becomes something now. Even, I'm going to say it's definitely going to be 2 or 3 because this is linear and now we're going to start growing more. This is compounding. Okay. Um, I'm going to say it's this one because it's only being divided by 4. It has a smaller denominator, so it's a bigger number. But let's just make sure. Okay, so we have option 1, and instead of 5, we're going to use 15. Move this up. I always like to double check my work and my thinking. So instead of 5, it's going to be 15, and I'm going to pull up my calculator, and instead of rewriting everything, I'm going to go, no, just enter. Okay, and instead of 5, it's going to be, enter, 15, enter. Okay, that's $950. All right, $950. Okay, now that was for option 1. Option 2, okay, go back to my calculator. I'm going to highlight option 2, okay, and I'm going to change my T, right, from 5 to 15. Okay, hit enter, and that's $1,056.85. So I have, for this one, $1,056, right? Let me double check. Oopsie. $1,056.85. 85 cents, and this is option 2. Move this up. Option 1. Okay, option 2. Okay, and that was this equation. That was this equation, and instead of 5, it was 15 inside the parentheses. Okay, now we have option 3, and again, I'm going to just copy and paste this. Oop, this should say 3 here. I'm going to copy and paste this. Oop, this lost this. Option 3. Okay, and this is going to be a 15 in here instead of a 5. And I'm going to pull up my calculator, and I'm going to take where option 3 is, highlight it, hit enter, and then I'm going to change my exponent. You don't have to do it that way. I just prefer to do less work on the calculator. Hit enter, and we have $10.93 or $1,093.33. $1,093, and what was the cents? And 33 cents. Okay. And so I knew this because I know that exponential is going to grow faster than linear. It's going to outgrow it, right? And I already saw in this example that the numbers were quite close to each other, right? And this outgrew this, so I knew that that was going to happen again, right? I could also tell because of the denominators, right? This was a bigger portion. This is a bigger portion of 4 than it is of 12. Okay, so it has a higher growth rate. All right, so let's take a look at number 5, right? At the time a new hat company opened, it had 50 hats in stock. Okay. The company planned to increase inventory by 2% each day, which represents the number of hats in stock after 3 weeks. So, after 3 weeks. Okay, so 7 days a week for 3 weeks. Oh, I love the way that's written. So my problem with this is there is no N there. So it's not going to be this one, because remember our equation is going to look like, okay, and I'm just going to change stuff around. 50 hats is our initial. We have 2%, and it's 7 days a week, and 7 days a week, and we have 3 weeks. Okay, so that's this one, right? 7 times 3 is 21. Let's check it out. And that's the only one I see that matches. Huh. Oops, I made a mistake. Okay, I see where my mistake was. It's not compounded. What am I thinking? I'm using the compound interest formula. Okay, so even I make mistakes because I'm going to be honest, I haven't done this that much. So it's kind of new to me too. So I understand where you guys are coming from. It's a lot of new material, but you can do it. So, and I did check, and like, that's what you should be doing. You should be studying and checking to see your answers. Um, so this is not compound interest. This is actually regular old-fashioned interest over here. Okay, and it's to the 7th, right? And how many times? 3 times, so, or to the 21st. So, I mean, that's how I would even just do it. I wouldn't even do it. It's 21 days. Okay, so let's see. This, so 3 times 7, because remember the power rules, if there's an exponent outside of the parentheses and there's another exponent, those are getting multiplied. So this is one of the answers. And then we have this as well. So if you're still questioning why I didn't choose this one, it's because it's not compound interest, okay? We're using our regular formula that we have been using for our expressions, okay, for growth and decay, okay. And that would be it for that one. Okay, the amount of chemical in a body when initially measured was 13 point, right? I'm going to put initially measured 13.4 milligrams. Okay, it decreases by 1% per hour. I love that it's per hour. Okay, which expression represents the amount of chemical left in the body after 1 day? Okay, so our initial amount, 13.4. Okay, it decreases 1% every hour, so there's 99% left every hour, or you could say 1 minus 0.01. Okay, and it is 24 hours is your exponent. So let's see, what do we have here? Which one is it? It is going to be, right, it's decreasing. So inside here, ooh, I don't like this. at all. Okay, so I think there's a mistake on this thing. It should be 1 minus. So it would be 1 minus, okay, because it's decreasing. All right, and okay, and this should also be 0.99. I'm going to fix that in our stuff as well. Okay, it should not be adding because it's decreasing. Okay, so given each function, state the initial value, okay, if it's growing or decaying, if the function is growing or decaying, and the percentage of change. And then it wants you to find it if your input, right, has the value of 4. Okay, so the initial value, this is pretty easy for you guys, 2.56. Okay, I'm just going to write it out. 506. We all know it's the A part of the formula or equation. Okay, now is it growth or decay? If it's less than 1, it's decay, right? It went down. If it's more than 1, it's growth, right? If our growth factor, I should say, right? This is greater than 1, so it's growth. This is less than 1, so our growth factor decayed. And this is greater than 1, we have growth. Okay, percentage of change per year. Okay, so it went down, right? 15%. So it decreased 15%. It increased, right? 35%. I'm just looking at where the decimal spots are. Okay, so you move it 2 spots. So this increased, okay, 2.5%, because I moved it 2 spots. It goes between the 2 and the 5, right? This decreased, okay, this decreased 5%, and this increased, if I have this correct, 200%. Okay, oh no, 100%, sorry, 100%, it doubled. Okay, now if it was 4, this is a pain in the butt to rewrite this all over again. You're going to put in the calculator. I'm actually going to do the stow function, so I'm going to do 4, just because I'm going to be writing these equations out all for when x is 4, so 4 stow x, enter. Okay, so now all my x's are 4, so I don't have to keep going around. 2.56 times 0.85 to the x. Okay, so my answer there is 1.34. Okay, now we have 76 times 1.35 to the x, and that is 252.43. 252.43. And our next one is 506, right, times 1.025 to the x. Okay, and our answer to that is 558.53. 558.53. And now I'm just going to give you the answers now that you know how to do it, because I have the answer key and I just want to move on. So we have 61 61.920. Okay, and our next one is 96. Okay, let's take a look at number 8. There's only a couple more questions left. So number 8,